My name is Pedro. I work for Protocol Labs. I'm a software engineer there. And I'm here with André Cruz. He's going to do some live coding today.
Hopefully, everything will go well.
We'll pray to the demo gods. Today we're here to talk about building decentralized apps on the permanent web. First of all, who are we? We are a working group in IPFS called the Dynamic Data and Capabilities Working Group. We fight crime, we fight alien invasions, and in our spare time, we do other stuff like research and development of the building blocks that people that are building dApps may need to use. Like we concern ourselves with security, identity, access control, concurrency, synchronization, and offline and near real-time collaborative data on top of IPFS. So we're a bunch of people. We have bi-weekly meetings. We have an IRC channel, and we also have a bunch of open GitHub repos that you guys can and gals can come and participate. Some key accomplishments of this working group. It's a very recent working group, but we have PeerPad, which is a fully decentralized collaborative text editor, kind of Google Docs, but completely decentralized. Delta CRDTs, which is a JavaScript library for doing CRDTs Delta-based. We have put out 2 research RFPs for stuff that we need on the CRDT lands. And also we have we are very concerned with identity. And so we have an identity RFC that if anyone is interested in participating in this discussion about identity on decentralized apps, I would love to hear your thoughts on this RFC, which we'll link at the end of the presentation. Also have PeerStar app, which is a library that helps decentralized apps build collaborative documents and generic data structures with, which is what we're going to show off next. So, André.
Yeah. So, building dApps. So, let's ask Google, how can we build a dApp? Yeah. So, I just went to Google and typed building dApps, and all the results came up being Ethereum or any blockchain at all. And so blockchain. What does a blockchain mean? So I'm not going to actually read all of this because everyone knows that a blockchain is just a linked list with some extra steps in it, right? So Ethereum-based blockchains, what are the advantages that they give us to us? So there are no central servers, of course. Code runs on every node. We've got strong consistency of the state, and the code and the state are tamper-proof, which is actually very good. Some downsides of it. So transactions can take a while, on average 15 seconds, but it can take more. Transactions have a small cost associated, of course, and it's very expensive to store a lot of data in a single transaction. And it's not offline friendly because we need to have a connection, online connection to the network to operate. So is that it for apps, or is there any alternative ways that we can build dApps nowadays? So our goal here, and I'm actually doing some live code session right next. We're going to do a simple to-do list application, and our goal is to be collaborative and real time. Okay. So let's first do an exercise and let's think about it. In a Web 2.0 version, centralized version, what components do we need? I will say we need a static web server to serve the application assets like the CSS files, the JavaScript files. We'll need a database to store the to-dos list. We'll need probably a RESTful API in order to interact with the database, like to push some to-dos, to read the to-dos, and so on. And of course, to perform the real-time updates, we'll need a real-time server, like for instance, an OJS server with Socket.io or something like that. And but we're not going to do anything centralized here. We're going to do it the decentralized way without any blockchain. But our goal is still to have a decentralized solution where any node is similar to others in the sense that they are simple, so there are no special roles, and every node is irreplaceable. So I'm going to get out of the presentation and do a live coding session in order to transform a to-do application that runs local on my machine. I'm actually going to just start the application so that you guys can, so that everyone can see. I don't know if you can see it well on your screen there. So this is a simple to-do application that is running on my machine, on my local machine. It's not decentralized in any way. So just for everyone to know the features of the app, I can just like type some to-dos, like buy candies, walk the dog. I can mark a to-do as completed. I can remove to-dos, and so on. So what I'm going to do is to create a decentralized version of this hub. And in order to do that, the first thing we're going to do is to pick into the to-do store file, which is essentially what we're going to change to make it decentralized. And the most important part to understand is that we have a bunch of functions. In this case, the load function, which is responsible to load the to-dos from the local storage. We have the add to-do, which adds the to-do. We have the to-do remove by ID, which essentially removes the to-do. A plate title, which essentially plates the title, like if I put something like that, it calls that function. And also the plate completed, which essentially when I mark the to-do as complete, it calls these functions as well. So what we need to do is focus on this file and make it decentralized. So as Pedro said, I'm going to import a library called PerStar app, which is our latest endeavor in this domain of making things decentralized. And I'm going to create an app, and I'm going to give it a name, which essentially, the name gives us like an isolated room where peers meet. So it must be the same name for the peers to reach out. I'm going to just name it To-Dos dApp. We don't need that. And now I'm going to start by rewriting the load function. What we're going to do is to start the app. This is a synchronous function, so I'm going to just wait for it. Then I'm going to create a collaboration on the to-dos list. And to do that, I'm going to call the collaborate method and give it a name. In this case, I'm just call it to-dos list. Essentially, you can have as many collaborations as you want in a single application. But for this demo, just one. And the second parameter of this function is the CRDT type. So PerStar uses CRDTs to essentially have conflict-free and replication of data and state. And essentially, any replica will eventually converge to the same state. In this case, I'm going to use the RGA CRDT type, which is essentially an array, basically, because our data model is an array of objects. Next one, I'm going to assign. I missed here. Oh, wait. Next one, I'm going to read the initial to-dos from the CRDT, and to do that,
to start the collaboration.
The collaboration? No,
No.
It's okay, it's okay. So I'm going to read the initial value of the collaboration. So I'm going to get that by accessing the shared property, which is the CRDT instance, and I'm going to grab its value. And finally, I'm going to return. But we are missing here, of course, the variable collaboration. And the collaboration is an event emitter. And we want to listen to state change events, not only from ourselves, but from other replicas as well. So I'm going to listen to the state changed event. And I'm going to update the to-dos variable again with the new shared value. And also, I'm going to call the publish state change function, which essentially informs the application about the change of the to-dos array. Cool. Let's just test it out just to see if there's some error. Okay, I think it's fine. So right now it's just an empty list of to-dos. Let's keep going on with the next functions. So in the add case, I'm not going to mutate the to-dos list manually. Instead, I'm going to use the CRDT to perform the mutations. So in this case, we're going to do collaboration, shared, push, the new to-do. The push is a method specific for this CRDT type because, as I previously said, is an array. So it has a push method available. I'm also going to do the remove part, which essentially just call remove at and pass the index. Going to copy that and do the same for the update. In this case, I'm going to call update at index and pass the new to do. Yep, sorry, comma. And the update complete function is basically the same as the previous one. Cool. So, in this version, everything should still work locally. So just gonna try it out. Walk the dog, buy some candies. Okay, mark is done. So yeah, it's working correctly. One thing to notice is that I was previously using the local storage to store the local to-dos in my browser, but because PeerStar already does this for me under hood, I can remove all this code. So all the code that has local storage can be removed. I'll just get rid of it. So this is becoming much simpler now. So before actually testing if other peers can collaborate on these to-do lists, we're going to draw a simple circle with a peers count so that we know how many people are collaborating on the to-do list to see the amount of people or peers. So in order to do that, I'm just going to copy some HTML. It's a very simple HTML to render the circle. This case, this is the HTML. Just gonna put it in the footer, right there. I also need some CSS to render the circle. So put it there. I'm going to put the peers count in the state. This is a React application, by the way. Going to put the initial value of the state to 1. And now we need to know whenever the membership or the peers have changed to update the peer counts. So we're going to subscribe to the to-do store, which allows us to know whenever that happens. And I'm going to do set state, peers count, peers size, because this is a set. And I'm going to implement that on the to-do store. So this is pretty much similar to the publish state change that the React app is already using. I'm just change state to peers. Going to need a new set for the peers. Okay. And to get the peers change or the membership change, the collaboration emits an event called membership changed whenever that happens. And I receive here the peers, and I'm going to call peers state change, publish peers state change, sorry, with the peers. Okay, and finally, I need to implement the subscribe peers, which is being used by the application itself. Subscribers, peers. Okay. Let's see if we see it working. So yes, one peer. And if I open, I'm going to split my screen. And I'm going to simulate a new peer by opening Safari and access the same application. This might take a while to get for the peers to see each other. Let's hope it works. Okay, we see two on the left. So the left peer is already seeing the right one, and the right one already sees the left one. Let's see if we can collaborate together. So I'm going to do buy candies. Sorry, uppercase. Buy candies. Buy candies. Okay, it seems to work. So walk the dog. Cool. I can mark it completed. I can remove to those. So let's see if this works offline, shall we? So what I'm going to do is I'm going to disconnect from the Wi-Fi. I'm going to change something on the left, like an A. I'm going to put a B on the right. And I'm going to connect to the Wi-Fi and see if the, like when the peers come online, if the state converges to the same value. Hopefully this will work. It might take a while, but hopefully it will work. So the left peer already sees the A, the B in this case. Yeah, so it works. So this was real-time collaboration without a blockchain using peer startup, which essentially is on top of IPFS and CRDTs. So to finalize, I'm going to deploy these on IPFS because we're missing the important part of becoming 100% decentralized, which is essentially deploying on IPFS instead of using a web server. So I'm going to just do that. And the first thing we need to do is to change a property on the package JSON because these are create React app application. They give us the ability to just specify home page, and we will use a dot so that all the assets are relative instead of being absolute. This is a requirement on every app of IPFS, hosted or deployed on IPFS, and I'm going to build a project. And while it's building, I'm gonna spawn the IPFS daemon. So it's already running. Let's wait a bit for the production build to end, which is basically an optimized version of the application for production. I should have started it before. Okay, so it's finished. So as you can see, the build comment output the build folder that we need to deploy in IPFS. So to do that, I'm going to do IPFS add -r so that it's recursive. And I'm going to specify the build folder. So IPFS just added those files, and the last one was the folder, the build folder, and the
root hash.
Yeah, this is the root hash of the directory. I'm going to copy that, and I'm going to open my local gateway and access to the application. So localhost, it's 8080, I think, IPFS, and the CID. And it works. So this is the decentralized version using IPFS as the asset server of the files.
You can wait until it converges. Now we have 3 peers.
Yeah. We have 3 peers, the previous 2 tabs, and this new one working all together on actually different domains, because while localhost is the same, they're running on different ports. So I think that's all for the demo. Obviously, you could deploy on your custom domain using DNS and so on, DNS link. But we are getting alpha time, so we're going to continue with the presentation.
Yeah, you can also check this workshop here on this URL if you want to try it out at home on your own time. And feel free to post issues and ask us questions about that here or on the repo. So continuing, so this PeerStar app, we've already deployed that on PeerPads, which I already talked to you about. It's a full decentralized private collaborative text editor. It adds a few features it uses a few features of PeerStar app that we haven't shown you, like having the ability of having a read key and a write key that you can share with anyone that you want to collaborate with. Also, yeah, this is PeerPad. You feel free to try it out. Also, Discussify is coming soon. It's a fully decentralized platform for creating discussions on anything on the web. It's being built by André's team. And these two apps are like the testing grounds for paving the way for how to build new dApps on top of IPFS that rely on collaborative, real-time, dynamic data. If you want to get involved, so I invite you to go to this GitHub repo. It's called Dynamic Data and Capabilities. It's the home of our working group. And we have all the pointers there if you want to participate, share your thoughts and ideas. As I said, we gather every 2 weeks in a meeting to discuss these things, but we are online all the time. So now, perhaps opening this to questions.
Was it too magical or?
Yes.
Do you have any authentication or authorization schemes you can use with this? Because it seemed like if you know the string, you can just do whatever you want.
Yes, of course. So the question of whether we had some authorization or capability schemes. Yes. So there is a basic one that's already in PeerStar app, which is you can create a set of keys, a read and a write key that you can choose to share with anyone via URL or off band. And once you do that, the read key will encrypt all the data being transmitted and stored. And the write key will be used to sign that data so that people can validate, so other peers can validate whether the signature is correct, whether to accept or not that message. But we are working on more evolved capability scheme, but that's on the brew still. So to have a crypto ACL on top of this CRDT thing that we've built, and tied with that identity parts that we're also developing.
We are also working on having an identity solution using the IDs and the verifiable claims and the IDL. We are working on having that integrated on PeerStar app as well. Actually, there's an RFC on PeerStar repo, I think, which has basically the proposal, the overall proposal on how to do that. Because being a peer-to-peer application, essentially you have to verify other people's data. You have to encrypt and decrypt other people's data, and we need to come up with a solution that packs all together in a user-friendly way, either for developers and for end users. So that RFC has a strong focus on that aspect.
Yeah, and I invite you to go to PeerPad. This is all fully open source. It's like an open product. We want people to fork it and change it and do whatever they want. Peek under the hood and see how it's done. PeerPad uses the thing I described, the keys that you may want to share with people that you want to collaborate with, and some other stuff inside that. So I invite you to take a look under the hood and put any question that you want in there, and Discussify soon also.
And Discussify is a little bit different in the sense that the discussions will actually be public. So there will not be any encryption and decryption, but it will be like you have to verify if the comment is authentic, right? So you have to verify signatures, you have to sign stuff, and peers, so peers can trust other comments from other peers as well.
Yeah. Any more questions? No? Okay, thank you. Thank you very much.
Thank you very much.